Hey, hi again. Catching up with my lessons on logarithms and exponentials. So half-life questions. Here's an example, and there's the formula there. For me, I always write final equals initial, but if you want to make it more funky, it's n of t equals n naught half to the power of t over c. N of t is just the final amount. This is the initial amount, and the c is the half-life constant. So the catch for these kind of questions is sometimes they ask you, what's the half-life? If they ask you what's the half-life, then you're asking you for C. If they say, how long does it take for a substance to go from 500 grams to 200 grams, then you're looking for T and not the half-life. So let's read this question together. The half-life of plutonium-239 is 24,300 years. If a nuclear bomb released 8 kilograms of this isotope, how many years would pass before the amount is reduced to 1 kilogram? Maybe not, this is not the happiest question. Yeah, it is sad, but anyways, just look at this and maybe we could ponder on how much evil is in this world, But on the happy side, we're going to do this question and get you an A on the test. So there you go. So here, 24,000 years is the half-life. So basically C here is 24,300 years because they already mentioned the half-life is that. So that's C. If a nuclear bomb released 8 kilograms of this, so they release 8 kilograms. So that's your and not or your initial amount, so 8 kilograms. How many years would pass before the amount is reduced to 1 kilogram? So that's N of T is 1 kilogram. So to solve this, you're just going to plug in everything in this equation right here. So now we want 1 kilogram. This is the final. The initial is 8 kilograms. Times half to the power of T, which is what we're trying to find, how many years for 8 kilogram to become 1 kilogram, over C, which is the 24,300 years. That's the half-life constant for this substance. So the first thing we want to do, we want to divide 1 by 8, dividing both sides by 8 equals 1/2 brackets to the power of T over 24,300. Now to solve for T is an exponent, we have to resort to logs. So we're going to log the left side. So we have log 1 over 8. But when I log this side, so log on both sides to allow me to bring the T over 24,300 in front of the log. And that's what logs do for us. That's one of the rules on logs there that we've done earlier. Log 1/2. So now just divide both sides by log 1/2 and divide this as well by log 1/2. We get 3 equals T, this cancels of course, over 24,300 years. Cross multiply that into the 3. So you just multiply 24,300 times 3 to get what T is, times 24,300 equals 72,900 years. Wow. So we're going to move on to another question. If 100 grams of AU-198 decays to 6.25 grams in 10.8 days, what's the half-life of the substance? Okay, so here we're looking for the half-life. We're given the initial amount to be 100 grams and decay into 6.25 grams. The time that it did that is 10.8 days. So here we go. We're just going to fill in this formula again. NT is 6.25 grams equals the initial amount is 100 grams times half-life, or half, sorry, times half to the power of T, which is 10.8 over C, what we're looking for. So again, divide both sides by 100, divide by 100, cancels, and 6.25 divided by 100, that's just going to be 0.0625 equals half to the power of 10.8 over C. Now we log both sides. Equals, the log will allow this to come down. Log a half, or if you wish, 0.5. Divide both sides by log 0.5 by log 0.5. And that will give me this gives me 4. So 4 equals 10.8 over C. When the unknown is on the bottom, is one easy step to solve. Free trade agreement, that's what I call it. The C goes where the 4 is, and the 4 goes where the C is. So this will give you C equals 10.8 over 4, which equals 2.7 days. Thank you for watching. Math is like a puzzle, and puzzles are fun to solve. Stay tuned for my next video. Don't forget to like, comment, and subscribe.